Good morning, good evening, or good afternoon, depending on your time zone. I am Anita Zanella, a staff researcher at the Istituto Nazionale di Astrofisica in Italy. Today, I'm very glad to be here and be able to discuss with you about the Audible universe, a project that I'm working on together with Chris Harrison and the members of the Sonification World Chat. The project aims at making astronomy more accessible to the blind and the visually impaired at the research, outreach, and the educational level as well. So according to the World Health Organization, it seems that 35 up to 40 million people in the world are blind. And this means that 1 person in 200 people are blind. But we have many more people with a visual impairment, up to 2.2 billion, depending on the definition. We are currently aware of 6 blind astronomers, and this means that only 1 over about 2,000 astronomers are blind. So this is really a tiny fraction of astronomers who are blind or visually impaired. And the main reason for this is that astronomy is traditionally thought to be a blind, inaccessible science. There are several reasons for this. So astronomy and astronomers use telescopes to collect light. Researchers mainly use visualization tools for research and as well at the mathematical level. And also astronomy is often presented as beautiful images to the general public. So there is a stark lack of blind accessible tools for astronomy research, making astronomy research difficult to access for the blind. But there is a problem that happens even earlier. So very often the blind children are excluded from astronomy education. So they don't have access to education of astronomy at school. However, there's no reason for this because we are all blind to the universe. With our naked eye, we can only see up to 1,000 stars. And then we need telescopes to see beyond these 1,000 stars and all the objects that are in the sky. Also, the visible light is just a tiny fraction of the electromagnetic spectrum. So we need telescopes and satellites to see most of the electromagnetic spectrum. And even more, we cannot see gravitational waves that are not electromagnetic radiation. And also 95% of the universe is not visible, and that's what we call dark matter and dark energy. So we are basically all blind to the universe, so there's no reason for astronomy to be a visual science. So challenging this idea, there are more and more groups working towards the possibility of turning astronomical data into sound. There are different ways to do this. So there is the possibility to use audification, that means to directly turn data into sound. And that's the case, for example, of the phonendoscope used by doctors or the Geiger counter used in physics. And then there is the sonification, that means to indirectly turn data into sound by the use of softwares or tools and the use of certain mappings that can be arbitrary. During the rest of the talk, I will discuss about sonification, so the indirect transformation of data into sound. Sound is naturally multidimensional. It has a temporal, a spatial dimension, but it also has amplitude, frequency, timbre, and many other characteristics. So it seems to be naturally very well suited for for the description of astronomical data that are very often multidimensional. So we have started to run a survey to collect information about projects that are currently sonifying astronomical data, with the idea to consolidate the knowledge and share it, first to collect it through the survey and then write up a review to share the knowledge that we are putting together. The idea is that many of the groups that are working on sonification projects are enthusiastic astronomers that are working mainly in isolation without sharing their findings. There is a stark lack of documentation and peer-reviewed literature, and having a collection of these projects will help first not to keep reinventing the wheel, but also to start working towards shared standards and also towards the evaluation of the effectiveness of sonification. So far, we have surveyed about 20 sonification projects. Most of them are led by US groups, but some of them are also based in Europe and some in Australia. The first sonification project we are aware of is Sonify Spec that started in 2016. And after that, many other projects started to arise, with most of them starting in 2019 and then 2020. So we are really in a moment of exponential appearance of all of these projects. So we think it's a good time to start thinking about what has been done so far, what is the direction that we want to take next, and to share the findings that have been obtained so far. So the motivation and the purpose of most of the sonification projects that we have collected is very different. Some of them focus on research, others on accessibility, on education, some on outreach, and others have an artistic purpose mainly. They also refer to very different audiences, so researchers, the general public, students from elementary to undergrad, and even families. Most of these projects, as I said, are carried out by mainly astronomers, but some of them also involve sound experts, such as musicians, sound designers, sound engineers. Some also involve visualization experts, computer scientists, and educations. The blind and the visually impaired are involved in 75% of the projects, although only in a minority of cases, they are co-designers or designers themselves. So we really encourage the different groups working on sonification of astronomical data to involve the blind and the visually impaired already at the designer phase and not only the testing phases. Sonification tools have been used to sonify very different kinds of data, from one-dimensional to two-dimensional, three-dimensional data, and even videos. Most of the projects are really multisensory, so beyond the sonification, they also include visuals and or haptic elements. So what are the next steps? So we would like to continue collecting this information and connecting the teams that are mainly working on in isolation. So if you're working at the sonification project and you didn't fill in our survey yet, this is the link. So please fill it in. We will collect your information as well, and we will not publish anything without asking your permission first. The next steps also concerned rigorous testing of the usefulness of sonification, not only for the blind and the visually impaired, but also for the sighted users. We would like to write documentation, including peer-reviewed publication, to share this knowledge and to help starting working towards common standards and to promote the use of sonification in research and outreach. To this aim, we are currently organizing a multidisciplinary workshop that will take place at the end of August, beginning of September. It will bring together the astronomical community with sound experts and educators, with the idea of indeed start sharing information and consolidate current knowledge and understand what are the direction we want to move towards. So the workshop will take place at the Lorraine Center in the Netherlands. It's only on invitation, but we will share the discussions afterwards and all the material that has been produced afterwards. So stay tuned and you will get to know what we discussed there. So I'll stop here and thank you.